Hello, everybody. Welcome back. We are here streaming again. Today is October 15th, Tuesday. We are back doing Python Crash Course. Um, Gonna be grinding away here. I'm on page 162. We just finished the try it yourself problems. We're moving on to, let me go ahead and do not disturb. Disturb. Cool. All right. So we are on working with classes and instances here on page 162 of chapter 9, which is about classes. Um, yeah, so let's go ahead and continue here. I wanted to expand my knowledge on classes, learn some more techniques here, and I'm going to be reading for about 45 minutes to an hour. Working with classes and instances. You can use classes to represent many real-world situations. Once you write a class, you'll spend most of your time working with the instances created from that class. One of the first tasks you'll want to do is modify the attributes associated with a particular instance. You can modify the attributes of an instance directly or write methods that update attributes in specific ways. The car class. Let's write a new class representing a car. Our class will store information about the kind of car we're working with, and it will have a method that summarizes this information. So we have class car, a simple attempt to represent a car, okay? And we'll initialize the car with self, we'll give it a make, model, and a year. Assign the instance variables self.make, self.model, and self.year to the attributes. And then we have another function which is get descriptive name, which is returns a nicely formatted descriptive name. Long name equals self year, year make model. Okay. And then we return the long name, and then we have new car, and we print new car dot descriptor new. Okay. So we're creating a method that we can use within our class here. In the car class, we define the init method with a self parameter first, just like we did with the dog class. We also give it three other parameters: make, model, and year. The init method takes in these parameters and assigns them to the attributes that will be associated with the instances made from this class. When we make a new car instance, will need to specify a make, model, and year for our instance. So because those attributes are in there and they're required, not by default being in there, not being default none, we uh, we have to assign them to create a class. We define our method called getDescriptiveName that puts a car's year, make, and model into one string neatly describing the car. This will spare us from having to print each attribute's value individually. To work with the attribute's values in this method, this will spare us from having to print each attribute's value individually. To work with the attribute values in this method, we use self.make, self.model, and self.year. Outside of the class, we make an instance from the car class and assign it to the variable new car. Then we get a descriptive name to show the kind of car we have, a 2024 Audi A4. To make the class more interesting, let's add an attribute that changes over time. We'll add an attribute that stores the car's overall mileage. To make the class more interesting, let's add an attribute that changes over time. Okay, setting a default value. When an instance is created, attributes can be defined without being passed as in parameters. These attributes can be defined in the init method where they are assigned a default value. Let's add an attribute called odometer reading that always starts with a value of 0. We'll also add a method read odometer that helps us read each car's odometer. So we don't give any new attributes to the class itself. We still have make, model, and year, but we assign a new I guess it is a new attribute. It's not a parameter. My fault. Okay. So what are the make, model, and years then? Are those attributes or those parameters? Parameters. Yeah, they're parameters. Okay. And then Yeah, so we give in line in this we add in a self.odometer reading. Let me go ahead and play lo-fi here. Actually, I probably don't need to play this because I'm reading, so let's just take that out. Right. Doesn't really matter. Why didn't this update? Let me try this over really quickly. Just want to make sure my live stream is working appropriately. Hello. I cannot hear anything. Why can't I hear anything? Let me just open up my Spotify. Let me just open up. Okay, for some reason my screen isn't updating. There we go. That was strange. Okay, got that fixed. Sorry about that. Okay, so let's go ahead and continue on here. So we added in this odometer reading 0 attribute. And then read odometer reading. This car has odometers on it. New car dot odometer reading. Not read odometer of your new car. Okay. So this time, when Python calls the init method to create a new instance, it stores the make, model, and year value as attributes, like it did in the previous example. Then Python creates a new attribute called odometer reading and sets its initial value to 0. We also have a new method called read odometer that makes it easy to read a car's mileage. Our car starts with a mileage of 0. Not many cars are sold with exactly 0 miles on the odometer, so we need a way to change the value of this attribute, modifying the attribute's values. You can change an attribute's value in 3 ways. You can change the value directly through an instance, set the value through a method, or increment the value, add a certain amount to it through a method. Let's look at each of these approaches. Modifying an attribute's value directly. The simplest way to modify the value of an attribute is to access the attribute directly through an instance. Here we set the odometer reading to 23 directly. My new car dot odometer reading equals 23. We use dot notation to access the car's odometer reading attribute and set its value directly. This tells Python to take the instance my new car, find the attribute odometer reading associated with it, and set the value of that attribute equal to 23. Yep, those are the updates to 23 miles. Sometimes you'll want to access the attributes directly like this, but other times you want to write a method that updates the value for you, modifying an attribute's value through a method. It can be helpful to have methods that update certain attributes for you. Instead of accessing the attribute directly, you pass the new value of a method that handles. It can be helpful to have a method that up. It can be helpful to have methods that update certain attributes for you. Instead of accessing the attribute directly, you can pass the new value to a method that handles the updated internally. Here's an example called update odometer. So we have def update odometer, which takes in the self instance itself and mileage, and then overrides mileage, takes in the new mileage given and overrides the self dot odometer reading. Okay. The only modification to car, in addition to update odometer, is the addition of update odometer. This method takes in a mileage value and assigns it to self dot odometer reading. Using the new car, my new car instance, we call update odometer with a 23 as an argument. This sets the odometer reading to 23, and read odometer prints out the reading. So we used a method to actually internally call it over and over again. Okay, we can extend the method update odometer to additionally work every time the odometer reading is modified. Let's add a little logic to make sure no one tries to roll back the odometer reading. So set odometer reading given to set the odometer reading to the given value. Reject the change if it attempts to roll the odometer back. If mileage is less than or equal to self.odometer reading, if mileage is greater than the original instance's odometer reading, we want to go ahead and override it. Else, print you can't roll back an odometer. Now, update odometer reading checks that the new readings make sense before modifying the attribute. If the value provided for the mileage is greater than or equal to the existing mileage, the instance of self.odometer reading, you can now update the odometer reading to the new mileage. If the new mileage is less than the existing, you'll get a warning that you can't roll back an odometer. Incrementing an attribute's value through a method. Sometimes you'll want to incrementing, adding to it through a method, modifying. Okay, now incrementing, which is add a certain amount. Increment an attribute value by rather than setting an entirely new value. Say we buy a used car and put 100 miles on it between the time we buy it and the time we register it. Here's a method that allows us to pass this incremental amount and add the value to the odometer reading. So we have def increment odometer with self and miles. Add the given miles to the odometer reading. Okay, so you're just adding to the, rather than overriding the call itself. The new method, increment odometer, takes in a number of miles and adds this value to the pre-existing instance self.odometer reading. First, we create a used car, my used car, and set the odometer at 23,500 by calling update odometer and passing it 23,500. Additionally, we call increment odometer and pass it 100 to add the 100 miles that we drove between buying and registering the car, and now you have 23,600 miles. Gotcha. You can modify this method to reject negative increments so no one uses this function to roll back an odometer as well. You can use methods like this to control how users of your program update values such as an odometer reading, but anyone with access to the program can set the odometer reading to any value by accessing the attribute directly. Effective security. You can use the methods like this to control how users of your program update values, such as an odometer reading. But anyone with access to the program can set the odometer reading to any value by accessing the attribute directly. Effective security takes extreme attention to detail in addition to basic checks like those shown here. So I remember talking about if it's not like a class method that can do something on the class, or it can be accessed, and then you can modify individual attributes that maybe you don't want to modify. Let's say you have a red car and it's remaining red, but the user wants to make it blue. Well, that would throw off your database, right? Because your car is red, and the user has access to like a method that could change the attribute of the car to blue. Okay, so now we're on the try it yourselves here. 9-4 and 9-5. So let me CD. Yes. C Python work. CD chapter 9. Touch 9 for number served. Right? So, and then let's just code this guy. So for this problem, we are asked with start with your program from exercise 9-1. Okay. Restaurant. Okay. So I have a restaurant. I initialize with a name and a cuisine type. I assign those instance variables. I have the parameters and I assign those attributes variables for the instance. We have a describe restaurant which just formats it, and then we have an open restaurant, and then we have a restaurant here which we took in and we printed and we did some stuff to it. Okay, cool. So start with your program from exercise 9-1. Add an attribute called number served and a default value of 0. So we don't want to add a parameter, we want to add an attribute. So this would be self dot number served is equal to 0. Create an instance called restaurant from this class, print the number of customers the restaurant has served, and then change this value and print it again. So let's go ahead, and now that we have this, we have created a restaurant here using our restaurant class. I'm just going to make this easy by calling it restaurant 1, right? And this title is called Olive Garden, and they serve Italian food. So we're gonna, of course, if I just clear this and actually run this program, nothing happens, right? Because we don't have anything being called to this class instance. So we want to create an instance, print the number of customers the restaurant has served, and then change the value. So we want to print, let's do F restaurant1 dot number served, right? That will print that message, and then we want to print it again. Let's go ahead and call this function one more time. Print it again. So print the number of customers served, and then this is update the value and print again. So plus equals to 1. Let's say we served 10 customers that evening, so that should work. So now if we run this, we get 0 and 10. Cool. That one was pretty easy. Add a method called set number served that lets you set the number of customers that have been served. Okay, so we're going to call a new method for our class here. We're going to be set numbered served, right? It's going to take in self, and then it's going to take in a number. Add a method called setNumberServed that lets you set the number of customers that have been served. Call this method with a new number and print the value again. So served let's make it easy, customers served, right? And then we are going to take our self dot numbered served, and we're going to add in customers served. And then what we're going to actually do is return this value, right? I'll just keep it in parentheses to be consistent. So now if I add a method, call this method with a new number, and print that value again. So use the set number served method to set the number. Okay, so print f self, or we want restaurant one dot we need to call a method to it. So let's do set number served, and we're gonna call 100, right? So now if we run, we get 3 values printed. We get the original, we get the one that we added 10 that we served to, and now we set it with 100. Cool, that worked. Add a method called increment number served that lets you increment the number of customers who have been served with any number that you would like that could represent how many customers have been served. I think it might have wanted okay. It didn't want me to increment here. Return this sets self dot number served is equal to customer served, right? So now if we call this, we get none. We need to return this. How did they do it in the book? They didn't return anything. Why am I returning none here? Oh, I need to call it and then print it, I believe, right? So yeah, because it overrode the value. So we need to call number served here like so, and then just we need to override restaurant one dot set number served with 100 like so. Right, and so that will print 0. So I'm not saving the value. not set number served. Self dot numbered served. Right, we want to set that. Now if we clear and run, we get our 100. Cool. So then for our next task that it wants us to do is add a method called increment number served that lets you increment the number based on its call. Okay. So def increment number served takes in self and then it takes in served. Then we take in self dot numbered served plus served, and then we're going to return this value. Right? You know, with return, we can just set the value like so with just served, and then we can call use the increment. Right? So now we can print an F string of right, restaurant 1 dot numbered served, and then what do we want to do to it? We want restaurant 1 dot increment number served, and let's do 1,000. So we served 1,000 people that night. So now if we save this up, clear, and then we run, we get the value we're looking for. So we start off at 0, customer served by default. We override the value by adding 10 to it and printing it. Actually, we don't override it, we just add 10 in this one instance here. We set the number, we actually override it with a method here, and then we actually override it again with this method here. So these methods permanently override, whereas this one does not, I believe. Interesting. Cool. So that is that one. So 9.5 login attempts. Okay. So 9.5 login attempts. Add an attribute called login attempts to your user class from exercise 9-3. So 9.3 user class. Copy this in. A couple of function methods here. We have describe and we greet. Okay. Add an attribute. Login attempts. Add an attribute called login attempts to your user class from exercise 9-3. Add an attribute called login attempts. This thing has a default value. Write a method called increment login attempts that increments the value of login attempts by 1. Okay. So def increment login temps takes in self and takes in amount. So then we just go self dot login attempts plus equal to amount, right? We increase it. Yeah. By 1. So actually, we don't want to make it modular. We just want to do increment it by 1. So then we want to create another method within our class called reset login attempts. And takes in self. And then I'm just going to guess that it makes self.login attempts is equal to 0. To 0. Make an instance of the user class and call increment login attempts several times. Print the value of login attempts to make sure it's incremented properly, and then reset. Use the reset call. Print login attempts again to make sure it's reset to 0. So we have user 1. So let's user 1 dot increment login attempts. Boom. We're going to do this 3 times. Print user 1 dot login attempts. We are going, so let's make sure that that's working. So this should show 3. Yes, 3. Okay, so now if we want to reset it, so user 1 dot reset login attempts. We'll call that, and then we're going to call that one more time. So now we should see 3 and then 0. And let's run. 3 and 0. Cool. Perfect. Make an instance of the user class, increment the login attempts several times, print the value of login attempts, make sure it's incremented properly, then reset the login attempts, print the login attempts again to make sure it's reset to 0. Great. Perfect. That worked awesome. So that was 9-4 and 9-5. So we're on page 167, inheritance. You don't have to start from scratch when writing a class. If the class you're writing is a specialized version of another class you wrote, you can use inheritance. When one class inherits from another, it takes all of the attributes and methods from the first class. The original class is called the parent class, and the new class is called the child class. The child class can inherit any or all of the attributes and methods of its parent class, but it's also free to define new attributes and methods of its own. The init method for a child class. When you're writing a new class based on an existing class, you'll often want to call the init method from the parent class. This will initialize any attributes that were defined in the parent init method and make them available in the child class. As an example, let's model an electric car. An electric car is just a specific kind of car, so we can base our new electric car class on the car class we wrote earlier. Then we will only have to write code for the attributes and behavior specific to electric cars. Let's start by making a simple version of electric car class which does everything the car class does. So we have our car class which has the make, year, and model, assigns the instance variables to those parameters, sets the default value of a attribute of odometer reading to 0. You have all that, and now we have a new class called class electric car, which takes in car, represents aspects of a car specific to electric vehicles. So we initialize make, year, and model, initialize attributes of the parent class, super.init make, model, year. My Leaf equals electric car Nissan Leaf 2024. We start with the car. When we create a child class, the parent class must be a part of the current file and must appear before the child class in the file. When we then define the child class electric car, the name of the parent class must be included in the parentheses in the definition of the child class. The init method takes in the information required to make a car instance. The super function is a special function that allows you to call a method from the parent class. This tells Python to call the init method from the car, which gives an electric car instance all of the attributes defined in that method. The name super comes from the convention of calling the parent class a superclass and the child class a subclass. We test whether inheritance is working properly by trying to create an electric car with the same kind of information we'd provide when making a regular car. We make an instance of the electric car class and again assign it to my_leaf. This line calls the init method defined in electric car, which in turn tells Python to call the init method defined in the parent class car. We provide the argument Nissan Leaf and 2024. Aside from the init, there are no attributes or methods yet that are particular to an electric car. At this point, we're just making sure the electric car has the appropriate car behaviors. The electric car instance works just like that of a car instance of a car, so now we can begin defining attributes and methods specific to electric cars. Defining attributes and methods for the child class. Once you have a child class that inherits from a parent class, you can add any new attribute and method necessary to differentiate the child class from the parent class. Let's add an attribute that's specific to electric cars, a battery for example, and a method to report on this attribute. We'll store the battery size and write a method that prints a description of the battery. So we have class car, and then we have our inside of our electric car subclass to our parent class car. We have we take the initialization, and then below the super function call, we put self.battery size equals to 40, and then we describe the battery with a method. We add a new battery attribute self.battery size and set its initial value to 40. The attribute will be associated with all instances created from the electric car class, but won't be associated with any instances of car. We also add a method called describeBattery that prints information about the battery. When we call this method, we get a description that is clearly specific to an electric car. 2024 Nissan Leaf. This car has a 40 kilowatt-hour battery. There's no limit to how much you can specialize the electric car class. You can add as many attributes and methods as you need to model an electric car to whatever degree of accuracy you need. An attribute or method that could also belong to any car rather than one that's specific to an electric car should be added to the car class instead of the electric car class. Then anyone who uses the car class will have that functionality available as well. Any attribute or method that could belong to any car. Okay, yeah, put it in the car class. And the electric car class will only contain code for the information and behavior specific to the electric vehicles. You can override any method from the parent class that doesn't fit what you're trying to model with the child class. Let's do this. Overriding methods from the parent class. You can override any method from the parent class that doesn't fit what you're trying to model with the child class. To do this, you define a method in the child class with the same name as the method you want to override in the parent class. Python will disregard the parent class method and only pay attention to the method you define in the child class. Say the class car has a method called fill gas tank. This method is meaningless in an electric car vehicle, so you might as well override this method. Here's one way to do that. In an electric car, fill gas tank. Self-electric cars don't have gas tanks. Print this. This car doesn't have a gas tank. Now, if someone tries to call fill gas tank with an electric car, Python will ignore the method fill gas tank in the car and run this code instead. When you use inheritance, you can make your child classes retain what you need and override anything you don't need from the parent class. Instances as attributes. When modeling something from the real world in code, you may find that you're adding more and more details to a class. You'll find that you have growing list of attributes and methods that your files are instances as attributes. Adding more and more details to your class, you'll find that you'll have a growing list of attributes and methods that your files are becoming lengthy. In these situations, you might recognize that part of one class can be written as a separate class. You can break your large class into smaller classes that work together. This approach is called composition. For example, if we continue adding detail to the electric car class, we might notice that we're adding many attributes and methods specific to the car's battery. When we see this happening, we can stop and move those attributes and methods to a separate class called battery. Then we can use a battery instance as an attribute of the electric car class. So we have class car, class battery, simple to the amount of battery from electric car. Takes in self, battery size equals 40. Battery size equals battery size by default. Describe battery dot battery dot we define a new class called battery that doesn't inherit from any other class. The init method has one parameter, battery size, in addition to self. This is an optional parameter that sets the battery size to 40 if no value is provided. The method described battery has been moved to this class as well. Describe battery. In the electric car class, we now add an attribute called self.battery. Electric car class. Self.battery equals the battery class. Okay. Has been moved. In the electric car class, we can now add an attribute called self.battery. This line tells Python to create a new instance of battery with a default size of 40 because you're not specifying any value, and assigns that instance to the attribute self.battery. This will happen every time the init method is called. Any electric car instance will now have a battery instance created automatically. We create an electric car and assign it to the value of myLeaf. When we want to describe the battery, we need to work through the car's battery attribute, myLeaf.battery.describe battery. This line tells Python to look at the instance myLeaf, find its battery attribute, and call the method describe battery that's associated with the battery instance assigned to the attribute. The output is identical to what we saw previously. This looks like a lot of extra work, but now we can describe the battery in much detail as we want without cluttering the electric car class. Let's add another method to the battery that reports the range of the car based on the battery size. So def get range is inside the battery, which is so if battery size equal to 40, range equals 1 to 50. If battery size is equal to 65, range is equal to 225. This car can go about range miles on a full charge is in the print statement for get range. So then when we call myLeaf.battery.getRange, the new method print The new method, getRange, performs some similar simple analysis. If the battery's capacity is 40 kilowatt hours, getRange sets the range to 150 miles. And if the capacity is 65 kilowatt hours, it sets the range to 225 miles. It then reports this value. When we want to use this method, we again have to call it through the car's battery attribute. In line 1, yep. The output tells us the range of the car is based on the battery size. Modeling real-world objects. As you begin to model more complicated things like electric cars, you'll wrestle with interesting questions. Is this range of an electric car a property of the battery or of the car? If we're only describing one car, it's probably fine to maintain the association of the method getRange with the battery class. But if we're describing a manufacturer's entire line of cars, we probably want to move getRange to the electric car class. The getRange method will still check the battery size before determining the range, but it would report a range specific to the kind of car it's associated with. Alternatively, we could maintain the association of the getRange method with the battery, but pass it a parameter such as car model. The getRange method would then report a range based on a battery size and a car model. This brings you to an interesting point in your growth as a programmer. When you wrestle with questions like these, you're thinking at a higher logical level rather than at a syntax-focused level. You're thinking not about Python, but how to represent the real world in code. When you reach this point, you'll realize there are often no right or wrong approaches to real-world modeling situations. Some approaches are more efficient than others, but it takes practice to find the most efficient representations. If your code is working as you want it to, you're doing well. Don't be discouraged if you find you're ripping apart your classes and rewriting them several times using different approaches. In this quest to write accurate, efficient code, everyone goes through this process. Okay, so we are on some more try it yourself problems here. Been streaming for about 47 minutes. I've read uh, 10 pages today. Cool. I'm gonna take a little break here. It's getting late. We streamed for about 45 minutes, 50 minutes. Learned to really polished my knowledge on classes. You know, I did know quite a bit of this stuff already through my practice and through Python, CS50P at Harvard and stuff like that. But I really wanted to solidify the knowledge further with the reading of the text. It really helps to see these examples, have them described, see the outputs live, see the different, types of ways you could go about it. The lectures in the CS50, they are just very brief and they don't do a lot of ins and outs and examples. They just kind of move on because they're trying to get the general scope of things. But this is really helping to solidify it and make everything more understandable. But yeah, I feel pretty comfortable with classes and accessing the attributes, the parameters, converting those into attributes, assigning attributes by default when there aren't actually parameters, changing those and stuff like that. So it's really, I found that I've been drawn to object-oriented programming ever since I learned it, because modeling real-world objects is what we kind of learn to code and why we are learning to code, right? We want to represent computer solutions in the real world, and so object-oriented programming was a way to do that. And so when I finally wrapped my head around it, I was like, wow, this is an incredible tool that I really need to solidify and with this book and get a deeper knowledge of. But I appreciate you guys for stopping by. Thanks for looking at this live stream. This was day 2 in a row of studying and programming every day. just going to be doing a lot of different resources. I do need to go back and watch another session of the MIT lectures, Mathematics for Computer Science, and maybe even start up the software development course to MIT, and maybe even the CS50X course offered through CS50. I got a lot of things I want to work on. Not a lot of time after work, unfortunately, before I get tired and gotta kind of just wrap it up because I've been working